Okay, discussion now is about long versus short-lived equipment, and this is a special case where we have equipment. I think about this as an essential piece of equipment in the manufacturing process that you're using. One example I use is if it's for my liquor company, Glenn's Discount Liquor, I might have an ice machine, and I'm always going to need an ice machine. And so I buy one and I use it as long as I can, and then when it doesn't work anymore, I buy another one. And so we have those kind of things, but when we have equipment that's going to last a long time and we're always going to be using it, sometimes it's difficult to decide whether we want one that's going to last a long time but costs a little more, or one that won't last as long but has a shorter life, is cheaper, has a shorter life but it's cheaper. And it's hard to see exactly how to make a decision on which one to buy based on our net present value rule. So we come up with another one called the equivalent annual cost. And let's just talk about how we would do that. So I've got an example here. We have two models. You might think about this as the ice machine. I could buy the deluxe model. It costs more than the budget model, but it lasts longer. It lasts 3 years instead of 2. And it's more efficient. What I have here is it cost me $15,000 today, and then it cost me $4,000 a year to operate it. You might think about that as electricity cost or maintenance cost, or both of them, both electricity and the maintenance cost. And the deluxe is a better machine. It's more efficient. It's easy to take care of. So it costs me less to operate, and it lasts longer, but it costs more now. Right? So the question is it worth paying more for the deluxe than the budget? I get an extra year of life and I save $2,000 a year. But is it worth it? Now, I can't just compare the present values, because the assumption here is that if I go with the deluxe model, then after 3 years I'm going to buy another deluxe and run it for 3 years, and then buy another one, and I've got an infinite series here. And for the budget, I'll save some money now, and then in 3 years I'll buy another one. Right? And so since these have different lives, it's difficult to compare just based on the present value of these cash flows. So we come up with this idea of the equivalent annual cost. Right? And the way we do that is what we try to do is take all the costs together, and in a time value of money way, spread that cost out over the life of the machine. So the first thing we do is we find the total present value of operating the machine today. So machine A costs $15,000 today, and then $4,000 a year for the next 3 years. So in terms of total present value, there's the number there. Right? Just took the present value of each cost for the next 3 years. I added that to the $15,000 I have to spend today to get it. And that says that in terms of present value, the total cost today is this much. Right? And then I'm going to use my payment key, the time value of money, to spread this cost out equally over 3 years. So it's $25,692 at an interest rate of 6%. The way to see this is what I'm doing here is I have NIPV, payment future value, and in terms of the cost today, for the deluxe, I've taken the total present value of all of the cost, and that's $25,692. So that's the present value I have today. All right, I want to know what payment that's equal to if I spread that out over the life of the machine, which in this case is 3 years, and I have an interest rate of 6%, and the future value is 0. Right? What payment is that? Another way I think about it is, for the amount of money I have to spend today, what payment would that support? And you could think about it as, if I were going to borrow all the money today to pay for everything in the future, how much would I have to pay back? Right? So I'm going to solve this using the spreadsheet. That's the numbers you'd put in the calculator. And that's $9,611.63. So that's saying that equivalently, if I operate that machine, it's like spending $9,611 per year. Now notice I don't spend exactly $9,611 per year. I spend $15,000 now and then $4,000 every year, but in terms of present value, at the interest rate we're working with, if I were going to spread this money evenly over the life of the machine, that's what it would be, right? So first I took the total present value of all the expenses, including the cost today, and then I spread that using the payment button over the life of the machine, right? So let's see, I have that here, $9,611. And then I can do the same thing for machine B. First, I find the total present value of all of its costs, so $10,000 today, and then $6,000 for each of the next 2 years. That's a total cost of $21,000. And I'm going to spread that over a life of 2 years. And that gives me an equivalent annual cost of $11,454. So that says, in time value of money terms, A cost me about $9,611 to operate, and B, on average, cost me $11,454 to operate. So I would rather have B. Since these are all expenses, these are dealing with money I spend, I'd rather take the smaller number. Okay? So that's saying in this case, the longer life and the lower expense is worth the higher cost today. Here's another example. I've got an old machine. I've been running it forever. You can say it's going to last 2 more years and cost $12,000 per year. But I could buy a new one now that will last for 5 years, and it only cost me $8,000 a year. Now, is it worth saving the $4,000 per year for 5 years if I have to spend $25,000 per year to get it? Right? That's one way to look at this. So the required return is 6%. Well, what I'm going to do here is find the equivalent annual cost of the new machine. Right? So the new machine, the first thing I'm going to do, I can find the present value of those 8,000 payments. That's how much it cost me to operate the new machine over the next 5 years. Then I'm going to add the $25,000 that it cost me to buy it today to that, and that's $58,698. I'm going to spread that out over 5 years. So the life of the machine's 5 years, interest rate 6%, find the payment that supports. And that turns out to be $13,935. So that's the equivalent annual cost of the new machine. It's $13,935. And that's saying, okay, if I buy this new machine, it's like spending $13,935 today. If I keep the old machine, it only costs $12,000 per year, so I'd rather just keep the old machine for now. Okay, here's an example problem for you to do. Find the equivalent annual cost of a machine. It costs $15,000 a year. It costs $4,000 a year to operate it. It costs $15,000 today to buy it. It's got a life of 6 years. Rates are 9%. So I've got the process here. Find the present value of the future costs. Then add that to what you're going to spend today, $15,000, and then find the payment you can get from 2. Right? And so that's a good one to practice right now. And let's see, I will solve that one for you on the spreadsheet. So let's see what we have here. We've got 6 years, the interest rate's 9%, and I've got $4,000 per year, and I want to know the present value of that. So N is 6, I is 9, payment's $4,000, the future value is 0. What's my present value? Let me just back that up here. I got the rate in the wrong place, so there's the interest rate, and the number of years is 6. There's the payment, there's the future value there. That's a better answer. So that's $17,000. This is the present value of the cost in the future, the 6 payments of $4,000 that I'm going to have to spend. I've got to add $15,000 to that. So my total, in terms of present value, the total amount that I have to spend today on that machine, the total amount that it cost me in terms of present value is $32,000. So I'll put that in as present value and then solve for the payment. All right, future value is 0, same life of the machine. So solving for that payment. That present value, no future value. And I get 7,343. So that's saying that is the equivalent annual cost of that machine. 7,344. So the answer to this one is C. Right, so it's worthwhile to take a few minutes and make sure that you can do that. Okay, let me stop the recording here. I'll pick up the next topic in the next recording.